Hi, Assalamualaikum. My name is Muhammad Izzuddin Hafid bin Azharuddin. Today I want to present about application of determinant in real life. What are determinants? Determinants are considered as a scaling factor of matrix. It is the scalar value calculated from given square matrix. Any square matrix can be associated with a real number. The determinant can be a negative number. It is not associated with absolute value at all except that they both use vertical lines. The inverse of a matrix will exist only if the determinant is not zero. In real life application, determinant used in computer graphics and computer vision. Determinants are used in computer graphics and computer vision applications such as 3D modeling, rendering, and object recognition. It can determine properties like the orientation, scale, and perspective of objects. In computer graphics, determinants are commonly used in computer graphics to solve various geometric problems and perform transformations. Some key applications include transformation matrices, cooling, intersection, surface normal. This example in transformatrix. Determinants are used to determine whether a transformation matrix is invertible. If the determinant is non-zero, the matrix has an inverse, allowing for efficient transformation computations such as rotation, scaling, and translation. The first example is translation, and then scaling, and third is rotation. Second, cooling. Determinants are employed to determine whether a polygon or triangle is facing the camera or not, aiding in the cooling process by calculating the determinant of the vertices of a polygon. You can determine its orientation in 3D space and determine if it's visible or hidden. Here is an example of cooling. First is cooling technique, and second is a cooling example. On the cooling technique, we can see the geometry outside of the frustum is removed, and then backface cooling. Third is occlusion cooling. Third is intersection. Determinants are utilized to find intersection between lines, rays, and plane. For example, in ray tracing algorithm, determinants can help determine if a ray intersects with an object or the scene. This example a ray traces algorithm. When the light source go to the object, it is in the view ray we can get the image, and camera we get the 2D shape. Third is surface normal. Fourth is surface normal. Determinants are involved in finding the surface normal of a polygon or triangle. The determinant of the vertices can be used to compute the normal factor, which is essential for lighting, calculation, and shading in computer graphics. Here is an example the surface normal, vector perpendicular to the tangent plane of the surface at a particular location. From this picture, we can see the matrices is used in calculating surface normal. And then computer vision. In computer vision, determinants are used for various tasks involving geometry, image analysis, and object recognition. Some prominent applications include camera calibration, image warping, 3D reconstruction, homography estimation. In camera calibration, determinants are employed in camera calibration technique to determine the intrinsic and extrinsic parameters of a camera. The determinant of the camera matrix is used to find the relationship between the 3D world coordinates and the 2D image coordinates. Here's an example. What is camera calibration in computer vision? A camera is device that convert 3D work into a 2D image. And this model of camera calibration, we can see pinhole and fish eye that used in a camera. Second, image wrapping. Determinants play a role in image wrapping and perspective transformations. They are used to calculate the transformation metric needed to rectify or align image, correct for distortion, or generate panoramic image. For example, we can see objective change appearance of image by performing geometric transformation, the original and the web. So image filtering, change range of image wrapping, change domain of image. This example we can see in image translation, rotation, aspect, find, perspective, cylindrical. Third, 3D reconstruction. Determinants are utilized in 3D reconstruction algorithms, such as structure from motion and stereo version. They help in estimating the depth, position, and orientation of objects in a scene by analyzing correspondence between multiple image or hetero pairs. For example, we can see clinical section which used in 3D graphic by the software uh, the and then reality scenes we can get reconstruct 3D model. Lastly, homography estimation. Determinants are involved in estimating homographies, which are transformation between image planes. Homography are used in applications like image stitching, image registration, and augmented reality. Example is image stitching. We can see in the camera panorama the image. We use the panorama, we get the in the first image stitching, augmented reality, like the filter which in TikTok we can see the animation filter they use in real life. And lastly, example image registration. Image registration process technique is to align multiple scenes into a single integrated image. It help overcome issues such as image rotation, scale, and skew that are common when overlay image. Image registration apply in medical. Conclusion: determinants provide valuable mathematical tools for solving geometric problems, performing transformations, and analyzing image in computer graphics and computer vision. That's all from me. Thank you.